Hello there, I'm Thomas Hatsios. Hello there, I'm Thomas Hatsios, the British American pilot flying the Boeing 777-300ER in tonight's flight from Zurich International Airport. We're going to be flying overflying Zurich, Switzerland, Germany, and then coming back to Zurich International Airport runway 14 for an Lszh localizer landing. So right now I'm in the cockpit for the pre-takeoff preparation of the Boeing 777-300ERX of the PMDG simulation and Microsoft Flight Simulator X. I'm going to start showing you the displays and the instruments of the cockpit of the Boeing 777-300ERX airplane. So I'm going to start with the primary flight display. The primary flight display that displays the airspeed indicated, the ground speed, the airspeed selected from the autopilot and flight director system panel, the barometric altitude above the sea level, and also the altitude target selected from the autopilot and flight director system panel, the rate of time descent of the aircraft tape in tens, hundreds, and thousands of feet per minute, also, and the rate of time selected from the autopilot panel. Also, we have the radio altitude above the ground level and the barometric pressure of the outside atmosphere displayed. And we have the magnetic heading and track, and the heading selected from the autopilot and flight director system panel. We have the magnetic north pole and the true north pole, and the magnetic variation depending on where we are in the world. We have the flight mode annunciator with the autopilot and the auto throttle, lateral and vertical navigation modes. We have the angle of attack of the aircraft. We also have the navigation display that displays the airports, the waypoints, the nav aids, the GPS position of the aircraft, and the inertial reference position. We have the terrain reflections from the weather radar with red, green, and yellow, and also with different altitudes like mountains and valleys. And we have also the sea and the lakes and the rivers displayed with blue, and we have the magnetic heading again on track. We have the next waypoint. We're going to be overflying the wind direction and airspeed, and also we have the RMP and the ANP, the required navigation performance, and the acquired navigation performance. We also have the autopilot and flight director system panels. So I'm gonna show you all these systems here inside the cockpit. As you can see, so you have the primary flight display here with the flight mode announcer, the navigation display, the autopilot here in flight director system panel, the upper and the lower ACAS, the thrust levers, the flight controls here. You can see also the rudder pedals, and also we have the overhead panel with the electrical, the hydraulic, the fuel tanks, the pressurizer system, electronic engine control, the flight control computers, and the ADIRU system. So this is some of the systems you're gonna see tonight. I will continue with the autopilot and flight director system panel, the autopilot and flight director system panel that displays the autopilot engage and disengage switch, the auto throttle left and auto throttle right engage and disengage switch, the flight director on and off engage and disengage switch. We have the airspeed select knob with the airspeed guidance of the aircraft in indicated airspeed of knots or in Mach, with the flight level change mode and the climb continuous mode, and the auto throttle hold switch with the speed mode. So we have variable thrust modes and fixed thrust modes for the thrust selected for the autopilot and auto throttle system. So we have the climb continuous and the idle thrust for climb and descent, and we have the variable thrust mode like the speed mode for cruise and approach and landing. So we have also the LNAV and the VNAV, the lateral navigation and the vertical navigation of the aircraft. We have also we have the bank angle select knob and the heading select knob, and we have the heading hold switch mode. We also have the vertical rate of climb and descent of the aircraft in tens, hundreds, and thousands of feet per minute, or in a trigonometric angle in degrees. We also have a few more modes. We have the altitude hold switch with the altitude select knob, and we have also the approach localizer for the auto land function of the autopilot and flight director system panel, and also the VOR localizer switch, the VOR log switch. So this is some of the things you're gonna see in the autopilot and flight director system panel. I told you about the navigation display. We also have the flight management computer. So we're gonna use the flight management computer to create a flight plan with the departure, airport, and runway, intermediate waypoints. We're gonna fly through in vertical and horizontal direction in the terrain map, and displayed in destination airport and runway. So we're gonna create a whole route for the aircraft, a flight plan. We're gonna use the flight management computer inputs. I'm gonna show you later for that. Then I'm gonna come to the thrust levers, to the upper and the lower ACAS, engine indication, the fuel air system display that displays the inputs from the FADEX, the full authority, the electronic control computers, and also in the overhead panel we have the electrical system, the left and the right engine, IDG, the great drive generators, the APU, the auxiliary power unit starter, the backup generators, the external power, and the batteries, the primary battery, the APU battery. So we have the IDGs, integrate drive generators installed in the engines, the left and the right engine gearbox that provides alternate curing for the aircraft, 115 volts, 200 Hz frequency, 120,000 kilovolts with left and right engine. I'm going to show you later. We have also the hydraulic pumps, left and right engine installed and driven, and electrical backup. We have also the ADIRU, the air dynamics reference unit. I'm going to show you all the systems in the overhead panel, electronic engine control for the engines, the auto start, the fuel tanks, left and right wing and center tank, the wing and engine RDI system, the cabin pressurization system, and the bleeder and the pressurizer from the engines, and the APU. We're gonna use the APU pressurizer for starting the engine. So this is some of the systems you're gonna see tonight. So thank you very much one more time for joining me in this video. I'm Thomas, that is the British American pilot flying the Boeing 777-300 international flight. I'm also flying the Boeing F-18 Hornet of the US Air Force and the F-22 of the US Air Force aircraft in other video, so you can see also that. So I'm gonna show you now inside the cockpit so you can see so we have about we have pretty much an hour left for this flight, so I'm gonna start with the primary flight display. You can see the airspeed indicated, the airspeed selected from the autopilot and flight director system panel, the actual airspeed, which is the ground speed is 0 right now. Because the aircraft is not moving in the ground, we have a barometric altitude of 1,430 feet above the sea level. The target altitude also selected from the autopilot and flight director system panel, 10,000 feet. The pitch ladder in degrees, the bank angle limits in the altitude display indicator, so you can see the flight director and the autopilot here for the lateral and vertical navigation modes. We have for manual and for automatic. We have here the rate of climb and descent of the aircraft. This tape, this is the altitude tape, rate of climb and descent, and airspeed tape, and this is the altitude of the aircraft. We have the takeoff ground modes now armed for takeoff. We have the radio altitude above the ground level, and the barometric pressure and the magnetic heading and track here. So I will show you now what I mean by this. We have also the airports, the waypoints here, the navigation display that shows the terrain map with the terrain level 6,100 maximum, 0 feet minimum. Also other aircraft flying around us, GPS and RNP and ANP. The required navigation performance and acquired navigation performance, the magnetic truth track here, and the ring of the distance here, this ring, so you can see how far away it's like terrain in front of you is being located, like mountains or the sea. So you can use also also here we have the barometric pressure in inches of mercury or in hectopascal, the meters for display, the range here for the radar, so you can see the terrain radar scan here, change the range if you need. We also have now 1013 hectopascals for the barometric altitude here, 1430 feet, and we have also 10,000 meters, 3050 meters, 10,000 feet, 1430 feet, 435 meters. So you have the pitch ladder in degrees and the bank angle limit with the flight director or the autopilot modes. So I will change this back to inches of mercury over here, the standard barometric pressure. So I'm gonna show you a couple more things. I will talk to you about the engines, the thrust levers, the nose wheel steering, the rudder pedals. I'm gonna show you the flight controls of the airplane, how to control it in flight, and also I'm gonna show you now we'll continue with the autopilot and flight director system panel. You can see the auto throttle left and right here systems with the flight director on and off. The flight level change here, I can change the airspeed select, so you can see this is the press box, so I will select a higher airspeed for the aircraft to follow, and also indicated airspeed or Mach over here. So both these two is depressible. You can turn off the flight level. Flight. You have to reset everything after turning off the flight director. The values. So you have also the climb continues, the auto throttle, the LNAV, the VNAV. All these are depressible. So you have the LNAV and the VNAV, the bang angle limit here. I will change this. You have also indicated airspeed and track. You can select this or deselect it. So you have the display of these two values. Also you can select the altitude here. The aircraft is gonna fly to. So I will select 253, 133, 136, 253 knots the airspeed, then the altitude to be 5000. So you will have here displayed in the selection 253 knots, 35,300 over here, the altitude and the flight level change, and also the heading 136 degrees here for the autopilot and the auto throttle. So you have also, you can see here this switch, the trim up and trim down of the horizontal tail, the autopilot disconnect. So you will show you a couple of modes more. So we have the vertical speed, flight path angle. You can select to descend or climb. You have the plus. So you have now this mode, the VS here, vertical speed, as you can see, with the heading select. We can select also the altitude here, another mode. So we can leave this. Also we have the flight path angle as well. So we have two overlapping modes here, so you can climb the descent. Also now trigonometric angle in degrees, minus or plus descent or climb. So you have also this one here. So you have the tick marks here of the degrees, or a mark here in the thousands of feet in the VS. So you will have the FPA, the flight path angle here displayed. So we have a couple more modes. I'll show you more quickly. We have the altitude also, hold either one with the heading. So now we're gonna have the altitude displayed here, and also we have the flight level change. We can connect the autopilot, for instance. I will show you now very quickly. You can see the autopilot connected here. Flight level change, speed with the autopilot on, and we can deselect it, disconnect. You will see over here the autopilot disconnect is red, and also the warning here in the display. We have no autopilot here. It's not no more in the display. So we reset this. We can disengage this as many times as we wish. We can also use this switch here, the autopilot disconnect. So this is will disconnect also the autopilot. So this is a couple of modes. You can leave this the way it is. So we'll come now in the thrust levers, perhaps. I will talk to you about the thrust levers of the other modes. We have an hour left. So we have an hour left for this video and this flight. I'm gonna show you the thrust levers now, how to activate the thrust. So we have two engines, turbofan turbojet engines installed in this airplane, the Boeing 777-300ER. We have the RB11 or the General Electric 90. So we have one engine installed for the left and the right wing, and each engine has a FADEC installed in its gearbox, which is self-contained in terms of electrical power. It's supplied by its own electromagnetic intact or with alternate current when the engine is working. So we have one FADEC installed per engine. The FADEC is the full authority digital electronic control computer, one installed per engine, dual channel. If one channel fails, the other takes over, controls and monitors all the displays that you see about the engine information, like the N1, which is low speed, low pressure, compressor stages of the turbofan turbojet engine, the exhaust gas temperature, the N2, which is the high speed, high pressure compressor stage of the turbofan turbojet engine, the oil pressure, oil quantity, oil temperature, and the vibration of the N2 stage of the engine. We'll show you now all these things. So when you move the thrust lever, so you engage the autopilot, you give a signal to the FADECs, the full authority electronic control computers, to control the fuel flow and the pressure inside the engine and the speed of the N1 stage. So the N1 is the low pressure, low speed compressor and turbine of the turbofan turbojet engine, the shaft of the low speed and low pressure compressor and turbine. So you have the N2, which is the high speed, high pressure stage of the shaft, high pressure and high speed compression and turbine of the turbofan turbojet engine. So you have two turbines and two compressors, a low pressure and high pressure, low speed and high speed, installed in the same turbofan turbojet engine. So this is how the turbofan engines are made. We'll show you that also for the modern airliner airplane. And you have the bypass also air. You have the front fan, you have the exhaust of the hot gases, of the accelerated hot gases. So I will show you all these things. You have the blades, the blades also, the blade stages, like 5 and 9 separate. So I will show you all these things. So you can see here we have the thrust levers. You can actuate the thrust by this. You can make the aircraft moving. We'll give a signal to the FADECs here. It will be displayed here the N1, which is low speed, low pressure compressor stage of the turbojet engine. Left and right engine, the limits 104.6% takeoff, go around, yellow, green and red, yellow and red for the exhaust gas temperature. You have the outflow air from the engines here. Some other information not related to the engines over here usually, and landing gear, flaps and total fuel. You can see the Boeing 777 here, the mark of the airplane, the N2, which is the high speed, high pressure compressor stage of the turbofan turbojet engine. The fuel flow per engine per hour, the oil pressure, oil temperature, oil quantity and the vibration of the N2 stage of the engine. So if you have the speed brakes extended and you move the you have the thrust levers at idle, you're in the ground, you move them forward, you will retract the speed brakes automatically. So you'll see the duct pressure here increase. Also the N1, the exhaust gas temperature. So you have this TLA, the thrust lever angle signal for the engine. So you have also other markings here, other limits. So you can use either one thrust lever separately, like this. You can move one thrust lever at a time, or you can move them both, like this. So you also have the auto throttle disconnect switch here. As you can see, the takeoff, go around, switch, the auto throttle disconnect. This engages the auto throttle, the thrust reverse. Here you can see other things besides the engines, like the flap settings. You can see the degrees, 1, 5, 15. You can move the flaps up and down, 15, 20, 30 degrees of flaps. So you have also the speed brake I told you, the pitch trim, the horizontal tail trim stabilizer. So if I move the thrust levers back, you will see the TLA signal, the reverse engages. So you have the blocker doors open now, the reverse of the airplane thrust over here. So you can see the blocker doors open, and the speed brakes extended. You can close it, you cancel the thrust reverse, also engages again like this. So you can cancel again the thrust. So this is the thrust reverse. You can slow down the airplane just after its landing. So I will show you a couple more things about the engines. I told you about the FADEX. One FADEX installed per engine, dual channel redundancy computer. If one channel fails, the other takes over, controls and monitors all the data that you see in the information in the upper and the lower ACAS about the engine, like the M1, which is low spill pressure, compressor stage of the turbofan to the engine, compressor and turbine, the exhaust gas temperature per engine, the N2, which is the high speed, high pressure compressor stage of the turbofan to the engine, compressor and turbine and shaft. And also we have the fuel flow per engine per hour, the oil temperature, oil quantity, and oil pressure, and the vibration of the N2 stage of the engine. We have also the outflow air from the engine. We have the pressure regulators, valves, the 59 stage, which also supply with pressurized air the hydraulic reservoir of the C1 and C2 hydraulic systems, and also supply with pressurizer the cabin pressurization system, the air conditioning and the ventilation of the aircraft, and the wing and engine RDI system. So the 59 stage of the outflow valves also they're controlled by the FADEX. If we have an overpressure inside the engine, the FADEX will control the outflow valves open to relieve the pressure inside the engine. If we have an under pressure or low pressure, the normal with the FADEX will control the outflow valves of the 59 stage of the blades closed, so it will increase the pressure inside the engine. This also optimizes the fuel air mixer as we climb or descend the aircraft, because we have different barometric pressures of the atmosphere depending on how high we climb or descend. Optimizes the fuel burn, also controls and monitors the engine start, the engine shutdown, other systems. Perhaps I don't remember quite well right now. So this is a few things the FADEX are doing. So they're a cool thing to have them installed in your turbojet engines. So I will continue with the rest of the systems now. I will show you the flight controls. Also, for this aircraft, the Boeing 777-300 ER, in this flight, we have 254,000 kilograms of takeoff weight. I will talk to you about the flight theory of the aircraft now. I'm gonna use the Newton's first, second, and third law of kinematics of motion of physics. Also, the Bernoulli theory of fluids. I'm gonna talk to you about some kinematics physics and mechanics, and also the aerospace engineering and aeronautical engineering, and some mathematics principles. So I will derive some things about the flight theory of this airplane, the Boeing 777-300 ER. So we have 254,000 kilograms of weight, takeoff weight, which is below the maximum takeoff weight for this aircraft. We have only 46,000 kilograms of fuel on board, which is 30% of the total fuel. In the left and the right wing tank, we have the center tank empty. So 46,000 kilograms of fuel, or 102,000 pounds, 254,000 kilograms of takeoff weight, or 523,000 pounds below the takeoff maximum. We also have 30,000 kilograms of passenger and cargo, about 46,000 pounds. So we have all in all in total 254,000 kilograms for this aircraft with 15 degrees of flaps and 4 degrees of horizontal tail or stabilizer trim. In takeoff we're gonna need 270 kilometers an hour of takeoff speed or 154 knots. So I will show you how you will achieve that. We need to overcome the stall speed of the aircraft. The stall speed of the aircraft for the given airfoil, the wings of the aircraft are gonna not generate the necessary lift force that is going to overcome the weight of the aircraft as we fly. So the airstream of the airflow of the air as we move forward into the runway for takeoff. So we need to be aligned with the runway and have 270 kilometers an hour or 154 knots for takeoff, a little bit higher for flying, and then coming back for landing. So I will show you all the stages of the flight. So you need to overcome the stall speed during the whole flight period. You can see that in the primary flight display, the airspeed limits, the warnings and indications, and also so I will show you how the lift is being produced by the wings as we move forward. I will talk to you about the flight theory of the aircraft, talk to you about the Newton section. So I will show you now a little bit about these things. So so you can see here we have the Boeing 777-300ER airplane. You can see we have two engines installed, one in its wing, left wing, and one in the right wing, to prevent the engine. This provides the necessary forward thrust propulsion vector to move the aircraft forward, not upwards like in other flying machines. So the engines can be used only to move the airplane forward. You can see the wings, also the symmetry of the wings and the fuselage. So you can see the wings can hold the weight of the aircraft in total. And we increase the wing surface area using all the flaps and the slats extended. You can also use flight spoilers in flight. You can extend to decrease the liftability of the aircraft. So as you move forward, you have this airstream of air coming forward from the front of the wing, from the leading edge all the way back to the trailing edge. So you have the bottom surface of the wings. You can see it's more flat, while the top surface of the wing is more curved. You have more curvature. So you have the bottom surface of the wings, the airstream of the airflow is moving slower, so you have higher air pressure below the wings, while above the wings you have higher curvature, so the airstream of the airflow of the air is moving with higher airspeed above the wings, so you have lower pressure above the wing. So you have lower pressure and higher, so you have higher pressure and lower airspeed below the wing. So the higher pressure will pressurize the wings up into the air as you move forward, as you accelerate and overcome the stall speed. So the lower pressure above the wings is going to also help creating the lift, the necessary lift force that is equal to the weight of the aircraft, the mass times the acceleration of the air gravity. So you also have a couple more things here in the wings. You have the mean aerodynamic chord position here, about 25% of the Mach of the mean aerodynamic chord position. Is also the center of the maximum aerodynamic lift and the position where the stall speed of the airplane is being calculated. So the wings of the airplane stall at this position. You make the aircraft lose its lift from its wings. So it's also the position where you place the center of gravity here of the airplane. You can place it forward or aft by moving the cargo and the passengers inside the aircraft. So we have a few more minutes before starting the engines. So you have also some other forces. You have the center of gravity here, so you can have the moment arm force using Newton's physics. So the moment arm is times the distance from the center of gravity all the way back to the horizontal or the vertical tail of the aircraft. So this distance from the center of gravity, this section, over the surface area of the horizontal tail or the elevator or the rudder, or you can use it from the center of gravity all the way out to the wings, left and the right wing, so you have a moment arm again. So it's this distance from the center of gravity to the horizontal tail, over the horizontal tail or vertical tail, as I told you, surface area, over times the airflow of the air mass as you fly per second, times the acceleration of gravity. So this gives the necessary force to pitch up the plane, the aircraft, through this vector, through the center of gravity vector and the forward vector that transverses the fuselage all the way forward in the nose. So you can pitch up, you can climb, you can descend, and also you can turn left and you can turn right, you can make turn right, and you can have stability and doing other things like holding altitude in this flight. So I'm gonna show you now a couple more things. So this is the main principles about the aerodynamic lift and flight theory of the airplane. I'm gonna show you now the flight controls very quickly, how to use the side stick or the yoke. Depending if you're flying a Boeing, you use the yoke. If you're flying on Airbus, you use the side stick. If you're flying on Embraer, you use the yoke again, or steer the airplane. So I'll show you now what I mean, and then I'm gonna come in the overhead panel. So you can see we have a CRJ again here in the runway for takeoff, another airplane. I believe it's a CRJ or McDonnell Douglas 80. So perhaps it's a CRJ, I'm not sure. So I will come now inside the cockpit, show you the flight controls of my airplane. So you can see I can climb, I can descend. I have this yoke here. I have also the horizontal tail stabilizer. I have the aileron trim, so you can use the horizontal tail stabilizer here. The position up and down, the pitch trim. We have also this stabilizer trim levers. You also have the normal and the alternate, and you have here the stabilizer trim cutout switches for the horizontal tail trim. In case you have a failure in the C or the R hydraulic system, you can turn off the hydraulic, you can turn off the automatic trim, the auto trim system from the autopilot and the auto throttle. So you disconnect this here, you have on the manual trim. You have the aileron trim here, so you can set the aileron trim and the rudder trim, the vertical tail trim over here, and see the position of the vertical tail trim and the aileron trim here. So you have some more things here. So you have the parking brakes here, up and down. You have the fire extinguishers for the left and the right engine. You have the fuel control to the engines. You have the transporter, the DSC transporter, and the weather and terrain radars, the radio communication panel. So I will show you also these things. So I will continue with the flight controls now. So you can see here I'm having this flight controls yoke, vertical, the elevator control, and the irons and spoilers control. I use the yoke, and I use the side stick for controlling this yoke. I'm using this side stick, so I'm gonna show you now, and I'm gonna show you how to use also the rudder pedals and the nose wheel steering tiller for ground operations. So it's different for air and different for ground and takeoff and landing. So I'm gonna show you how to use all these flight control system. So you can see here we have this side stick that I'm using for the simulator, as you can see. So I hope you have a better view. Maybe I need to add a little bit more light. So I'm using this side stick. You can see I can climb, I can descend. Using the side stick, I have a proportional input of the side stick position into the yoke of the Boeing 777 airplane. So I can climb, I can descend, I can leave neutral, I can bank roll left, I can bank roll right, and also do a coordinated turn with climb and turn, or the other way, turn to the right, or climb or descend and turn. And also use the rudder pedals over here. You can see the rudder pedals movement. So this is how you control the side stick. You can leave neutral, you can use the horizontal tail, the stabilizer trim, the thrust levers over here, position. You can actuate the thrust as you desire, and the speed brakes also. So this is the general principle of the flight controls using a side stick like this. If you use the side stick movement all around instead of the yoke, so you have good results with this Lszh Extreme 3D side stick. So now I'm gonna show you the outside view of doing the same things in the flight controls. We have a few more minutes left for this flight, so I will show you the operation of the flight controls in the horizontal tail, vertical tail, and using spoilers. I forgot to mention, you use this for nose wheel steering in the ground. This tiller in conjunction with the is overlapping with the rudder pedals sometimes. So you can see here you can see I'm using the elevator and the rudder here, and the allowance and the spoiler. So I'm using the side stick control again. So you can see I can climb, I can descend like this. I have full control of the airplane flight controls operation. You can leave neutral, you can make the rudder turn left and right, and also have coordinated flight controls, all the flight controls at the same time. So you can pitch up and pitch down, bank roll left and bank roll right, leave neutral position, and trim also it will help you out, and use the thrust lever. So this is the principles. I'm gonna show you now the overhead panel of the airplane, and then make the engine start demonstration of all the systems in the overhead panel, and the multifunction display with the systems like the electrical. So I will come inside the cockpit. So this is now the position of the airplane. We have like 30 more minutes for this flight. So I have to be a little bit more brief now. So I will show you this section now, the overhead panel. I will come now here in the overhead upper panel section. You can see we have these switches for the maintenance. In the ground we have these circuit breakers. We have a phaser, you can reset or change the circuit breakers. So this is a general view of the cockpit. Another one, you can have pretty much the same displays like in the other side. So you can see we have again the stabilizer trim cutout switches for the electric, for the other. We have the parking brakes again, up and down. The fuel control, we have also the flap settings here. So I can move the flaps like this. so I can move them up to the 15 degrees over here for takeoff. From this position you will see it displayed over here 15 degrees instead of 30. So you can move all the thrust levers again. You have the thrust increase here. You can see the limits. You can see also the same information. You can use the flight controls. You can see the autopilot here, information, the settings, and the SS panel. So you have a more general view of the same information. So maybe not having too much time to show you everything. So we have the ADIRU, the air data and Lszh reference unit that displays and monitors the air data control system with the pitot static, the airspeed, the barometric altitude, the rate of climb and descent, the radio altitude, magnetic heading and track, the GPS information and inertial reference, and the attitude of the aircraft. We have the laser gyroscope of the aircraft that display things like the acceleration and deceleration, so, and the heading. So very important controller, the ADIRU, the air data and Lszh reference unit. We also have the flight control computers. So we have the left and the right engine integrated drive generators, one installed per engine, 115 volts, 200 volts maximum, 400 Hz frequency, three-phase electromagnetic induction alternator, bipolar north and south pole, produces 120 kilovolts, 120,000 watts of electric power. Also the left and right engine, and 25,000 kilovolts the backup generators. And also we have the APU and another 120,000 kilovolts. You can convert some of these alternate current into direct current using the transformer rectifiers. You can also have the battery direct 28 volts current 48 ampere hours transformed to converted into alternate current using the static inverters. So also you also the hydraulic fluid pumps, left and right engine installed again in the gearbox, the electrical hydraulic pumps, the rammer turbine, and also the pressurizer from the left and right engine. I will show you the bleed air system and the fuel tanks of the aircraft and electronic engine control and the auto start. So this is for the overheat panel section. As you can see, we have the ADIRU here, the data Lszh reference unit. Over here we have the primary flight control computers. Over here the thrust symmetry compensator. We have the battery, the APU generator. I'm gonna start the APU here with this switch. We have the left and the right engine drive, the great generators, alternator and the backup generator, so you can see. So I will show you how to use them in a couple of seconds. We have the passenger oxygen here, the window heat, the rammer turbine, hydraulic left and right engine, hydraulic controllers. Perhaps we have the APU ready. We have also I will show you so you can see we have the hydraulics here. We can turn off even one, the controllers like this, turn on and off. So we'll turn off all the hydraulics and see what happens now here in the ACAS. This information display. You're gonna have the hydraulics failing on the system. So you can see the slats, all the flight controls are failing. We have the warning here, and it keeps coming out from systems. Flight controls, no brakes. So this is many systems failing. It comes to the warning. You come over here and you reset the hydraulic pumps over here to be on. When it turns on, the fault goes out. You can reset to the auto. Then you have back all the hydraulic pressure. So we have also the electric power. I told you we can turn on and off these generators here. So you have the APU on, it's no problem. You can turn off. You have the electric backup generators and all the systems. So we have about We have like a few more minutes left for starting the engines again, so I need to come faster for this display here. So this is the electrical system, the hydraulic system. This is the lighting system inside and outside the windshield wipers. We have the cargo fire and APU fire. We have the electronic engine control for the engine. The auto start of the engine here. Excuse me. So you can use this for starting the engines on and off. Controller. So also later you can dump fuel in flight if you arm this. This is the fuel tanks and fuel pumps for the NAF. You have the left wing and the right wing. So you need to on. You have the sender here. Tank is empty. So you turn this on again. Wing and engine are the eyes here. This switches on and auto. And we have the bleeder, the pressurizer, the parts here. You can turn on and off. So we close all this. See in the auto. You're gonna have a failure after a couple of seconds. So we close the pressurizer. You will see now it's off. So you will come here, you will see all these systems are off. The bleed isolation valve, bleeder, hydraulic pressure, C1 and C2, C2 and C1. So you lose the hydraulic pressure for the side controls, and also you lose you have no cabin pressurization of the airplane by closing these outflow valves of the pressurizer. Also air conditioning ventilation, and using the APU here for starting the engine. So I'm gonna show you now. We have also the cabin pressurization system of the airplane, automatic, manual. You can use the outflow valves for climb and descent to pressurize the cabin and select the landing already. So this is the general overview of the overhead panel. I will come now here. One last section before starting the engine. We have this display here. I will show you now. So you have the display on. You can see the engine, you can see the status, you can see the APU start here, the hydraulics, pressure, and the oxygen. You have the checklist, normal menu. So you have before start what you need to do. All the items to complete. You have a failure, you have to follow this list. You have the communications, navigations, the synaptics. So the doors of the airplane of the Boeing 777 are closed and the cabin is pressurized. The landing gear, you can see the pressure and the temperature. The pressure is the tires and the temperature of the brake. You have the left and the right, the electrical here. Engine and the backup generators, and the APU is on. You have the battery voltage and the discharge, so you can see this information about the electric aircraft. You have the hydraulic of the aircraft, left and right engine. The pressurizer, I told you, air pressurized here, C1 and C2. These tanks, hydraulic fluid, and also what it consumes hydraulic fluid, and the pressure 3000 psi system, 3000, 3000 and 3000. Left engine, right engine, and the backup electric driving. So you have also the fuel system, left and right engine, left wing, right wing. You have balance, same volume and of fuel in the left and right wing. The minimum fuel temperature here. The center tank is empty, and you have the low and high pressure valves open and the crossfit valves open. The APU also with the direct steering. You can see the total fuel on board in thousands of pounds. And the air here, the pressurizer system. So we have the left engine, right engine, the APU we're gonna use for starting the engine. We have the hydraulic pressurized here, C1 and C2, and the duct pressure. So also the cabin pressurization system. So if I move the thrust levers forward, you will see the pressure increase here from the outflow valve. So this is the 9th stage. So this is so much for the pressurizer. I will show you how to start the engine for using the pressurizer, and this is the flight controls. You can see all the flight controls are normal. You can see the stabilizer train positions in degrees. Stabilize. You can see the horizontal tail, the vertical tail, and the left and the right wing. You can move the flight controls, so you have full control here of the flight controls like this, and the rudder pedals. And the other side also you have no failures. So this is so much about this panel. You go back into the modes of the engine. So I will come now to start the engines in the cockpit. So I need to turn off both fuel valves to the off position here. Cut out the fuel valves. So you will see the N1 here decreases. Also the exhaust gas temperature. The N2, the fuel flow is 0. So you have the shutdown message here for the engine. I will come in the overhead panel now and set up the auto start, the left and the right wing auto start system. So you're gonna start having the spinning of the engines. You still have a low N1, as you can see the engine shut down here message. So this is a different condition here. So you have the N2 increases above 20%. I will show you now the other side view. So we have the spinning of the engines here, start spinning. As you can see, the left and the right wing turbofan is still slow because there is no fuel flow. It's only the pressurizer from the APU inside the engine. So you come here, you can see there is no fuel flow. So we start the fuel flow like this. The fuel control left and the right engine on. It takes a second or two and you have the fuel flow increase from 0 and the pressure and the speed of the rotation of the turbines. So we have both turbines on, fully working now. We have the fuel flow and the pressure. We have 5,000, 8,000 rotations per minute, and one less step left before takeoff. Very fast. We need to set up the flight management computer, the flight plan. So we said we select the mode here, the menu. We have the FMC, the model of the airplane, the position, initialize. We have the reference GPS position. So we enter the airport we are located and we request the GPS position coordinates. We have the 0 fuel weights. We just press this button and it's being inputted automatically. So we have the reserves. We select the reserves, the flight altitude here, the cruising altitude, and the cost index. And we have some other information like the center of gravity, cruising center of gravity, minimum fuel temperature, the route from this airport, Lszh, back, departure and arrival, and using this runway 14. So we're going the departures and the arrivals, departure airport and waypoints, and the arrival Lszh approaches -01 alpha. So we go departure arrival Lszh. So we have the departure here. Select this V2 alpha. We have it in the legs. We select wireless approach. Route 1. So we have the departure Lszh for the route 1. I don't know why I cannot select. So I will insert again the same information on Lszh. Runway 14. So we have now the correct input for departure and arrival. Selecting this and arrival, Lszh 14, transnegri over Alpha, Transamity. We had this problem, so we lost some time here. So fine, activate and execute, and we have the flaps here. The request 15 degrees center of gravity for takeoff, and V1 V-rotate the takeoff speed. For this flap settings, so we lose no time now. We have to taxi into the runway. We have a few more minutes left to go. So disarm the parking brake, use the pillars here. We have like 15 more minutes left to go for this flight, for this video to end. Lost a couple of minutes with the flight management computer, so I use the steering wheel and also so we go back. We have the runways open, advance the thrust levers again, use the parking brakes again, align with the runway first, and we have the information we need inside the cockpit for takeoff and for flying. So everything is ready. We only need to set the range here, the LNAV, and we set the thrust levers forward. We will see the thrust increase for the takeoff. We have also the flight plan here, so this is where we are in the runway, ready for takeoff. Runway 14, as you can see. So we lost some time with this video. We need to come faster for the takeoff. We just disarm the parking brakes and go. So when we reach the V1, we rotate, align with the rudder pedals here on the steering. So we have a few more minutes to go. V1, we rotate. You can pitch up like this. So we have the rotation speed here. Be careful not to hit the tail of the airplane as we climb. So we have the positive rate of climb here as we take off. We can retract the landing gear. Positive rate. The thrust is correct, as you can see. So we are just 1,000 feet above the ground level, 1,200. You can see the difference, the barometric above the sea level, 1,800 feet above the ground, 3,600 above the sea level. The airspeed 500 kilometers an hour or 250 knots. So we pitch down a little bit as we keep climbing and make the turn. So you can see the rate of climb here. We have the positive rate of climb. We're not descending. We have overcome the stall speed, and we have the flight plan here, the route. So we make the turn to the airport. We have maximum takeoff ground thrust. So you can see how we turn. We have like 14 more minutes left for this flight. So this okay. We keep climbing. Maximum climb power. You can see the information here in the display. You can pitch up a little bit, climb faster. So we have the runway. We're gonna see the runway in a couple of seconds. You can use this, the other ones in the spoilers, and pitch up a little bit if you need. speeds down. Also, you see the rate of climb is too much, and use the stabilizer thing. So this is the runways now. So this is as we climb out from the Zurich airport. The Boeing 777 will fly at about 500 kilometers an hour. So we're gonna see some nice view now of the outside of the airplane, of the Boeing 777, as we fly with 600 kilometers an hour, about 250 meters a second, 15,000 feet above the sea level, and about 13,000 feet above the ground level. So we keep making the turn. We have these nice views over here. The side view, we have also night sky. As you can see, we have the Switzerland here on the Zurich airport here. The whole view of the Zurich and the night sky. So we turn now to the other side. Keep climbing. So you can see we have reached the stall margin here. The stall is gonna make the aircraft fall, so you have to use the stall avoidance. You can level off. Over here you have the limit for the flaps, this red limit. So you can descend a little bit, increase your speed, and then climb again. So we're gonna cross the next waypoint now. So we have about 11 minutes left for this flight, approximately. So you can see we're climbing 30,000 feet. We're gonna have the German in front of us, the Bayern Munich, as we keep climbing. So I'm gonna cross this waypoint in front of us. So we're gonna have two waypoints as we climb 32,100 feet right now. You can see the airspeed is Mach 0.4, so we have the stall speed warning. This is the next waypoint we have to overfly now, 33,000 feet. Keep climbing. We have to level off a couple of seconds. So we have the chemtrails now. Over here. The chemtrails, as you can see from the airplane. This frozen vapor as we're trying to level off to the cruise altitude of 35,000 feet as we keep climbing. Slowly climb. So hope you like these frozen vapors from the airplane. So this is our spacecraft for tonight, the Boeing 777-300ER airplane. We are about 6,000 meters above the ground level and flying with about 700 kilometers an hour. So we're gonna keep climbing a little bit more. We have the lake here. We have the Germany in front of us, the Bayern Munich in front of us, the Bayern Munich area. So I hope you like this display. So this is our spacecraft for tonight, the Boeing 777-300ER. So we keep climbing, flying straight and level. We have the Bayern Munich and the Germany in front of us. So I go inside the cockpit now. So I'll show you now here. We need to come to a level of pretty much. We have like 8 more minutes left for this flight, so we need to start turning into the airport. We need also to increase the airspeed here. Increase the airspeed. and retract the flaps as we keep coming into a level of and turning like this. So hope you like this turn as we keep climbing to 35,000 feet like this, manual turn. So we level up here 35,000 feet manually as we keep turning to the airport. So now we're going with Mach higher Mach speed now. We can fly with Mach 0.6 or 700 kilometers an hour, 262 knots. We level up here and we turn back into the airport. Make this turn here. So I will show you a little bit outside the turn. We can also use the autopilot as we turn. The autopilot connect also. So we turn in here over, we leave the Germany, the Bayern Munich behind us. So we have this nice review of the Boeing 777-300 airplane. Hope you like it. And we're trying to level up. So we leave the Bayern Munich, the Germany, the Bavarian Alps behind us. We keep trying to level up. So this is our spacecraft for tonight. Now we fly with 300 meters per second or 900 kilometers an hour, about 7,000 meters above the ground level. So we have the Galaxy. So this is our spacecraft, this beautiful airplane, the Boeing 777-300ER. So we need to come now for the descent and approach into the airport as we keep turning. So I will come now inside and show you all how to approach and land the airplane. We need maybe to activate the autopilot and use the next waypoint here. Let's see 114 execute. So we're gonna come now for landing with the autopilot connected. We have simulation rate increase. So we're gonna use this here for descent, and the flight level change and decrease the airspeed a little bit. So the autopilot will give it a signal now for descent into the airport, as you can see, and we have 4 more minutes left for this flight. So we need to accelerate a little bit the simulation as we descend. So this is as we descend the Boeing 777-300ER. We're coming closer into the airport. We need to decrease also the airspeed as we descend to the approach airspeed. And also use the vol localizer and disarm the autopilot. So we keep descending. Also use all the speed brakes to descend to slow down the airplane. (16,000 feet). 15,000 feet. Use also the landing gear, maybe to slow us down a little bit. So we're flying manually now. We have the river here as we descend. So we need to slow down here. So we have the clouds in front of us, we have the river as we keep descending into the runway. So we're coming manually with just the thrust also, and along with the runway. 1 more minute maybe left for this flight. Exactly, 2 more minutes left. So we are very limited in terms of flight time for this flight. So here we are, 3500. Adjust the airspeed, coming closer into the runway. So you will see a higher speed landing with about 300 kilometers an hour of touchdown. So here we are, parking brakes and reverse thrust. We reverse, we slow down. So this is a takeoff ground again for this airplane, but we did the landing part. So that was